it was me. Thank you to everybody. And so, how this is going to go. So each team has about 5 minutes for pitching and sharing their project. So that will include demoing or whatever. Note that we're going to be running strict to the time. Then we'll have about 2 minutes for judges to ask questions. We'll introduce the judges in a moment. Multiple people will be allowed to present, noting that we only really have one mic and one camera, so we only can present two as one. I'll call the teams up one by one, also mentioning the next team to be ready to present. And then our timekeeper, Dani, will be dinging the bell for when you're at 4 minutes 30 in and when your presenting time is up. So, prizes. We'd like to give a huge shout out to Technology One for sponsoring Hackathon. They have been sponsoring Hackathon for years now. We'd like to thank them for their continued support. We have Matt Deshawn here. We'll introduce him in a moment. We all know what the prizes are. There is a lot of prizes up for grabs. The judges know what you have selected in your nomination form yesterday for what prizes that you're potentially going for and what you're eligible for. Now, People's Choice. Now, the audience also get to say there's a $200 prize for People's Choice. It's a tradition, so keep that in mind as we're going through the presentations. We'll give the link out at the end, and we'll keep the order up after that as well to make sure that you know what teams presented when. Now, we have our judges. So we'll start from my right to left, or actually left to right. So we'll start with Matt Deshawn. Matt has been working at Technology One for X amount of years. I'll get him to introduce himself with the mic.
Hi everyone. There we go. Hi everyone, I'm Matt. Ex-UQ, I did a Bachelor of Science here, Webscape, Computer Science. Working with Tech One for a long time now, and I'm the General Manager for our product division. So I'm very happy to be here. We're very proud sponsors of UQCS and the Hackathon, and we're continuing that long association. So thanks very much for having us, and we're very proud to be sponsoring.
Fantastic. Hello, I'm Gemma. I graduated UQ last year. I currently work in last year. I won Universe Mathematic project last year, so that was pretty fun. And I'm keen to see what people are going to be presenting this year. Yeah, good luck to everyone.
Hey everyone, I'm Taylor. I'm a former UQCS president from 2015 to 2017. I'm currently a senior software engineer at a small startup called Cubico, so in industry. But yeah, I'm really keen to come back here and do some judging instead of running the hackathon.
All right, so here's the team order. Hopefully this is the correct order at this point. It's been gone through a number of iterations today. But we're going to start off with, we're going to have 8 teams to start off with, 16 teams in total. We'll have an intermission from the lovely UQCS Jazz Band. Speaking of Jazz Band, we should probably give a big clap for their first introductory performance. Give them a round of applause. All right, I won't keep the judges waiting too long. Let's get Quokka first. And with Gambrel, if you can be ready to present next.
Is it still too late to back out?
Yeah, I think so. I believe we can't leave now.
Okay.
So, what do we do now?
We'll just here.
Yep.
Oh,
Okay.
there's a camera and everything.
Go for it.
Wait.
Go for it.
Hello. We are Quokka, I believe. Thank you. Yes. So I am Santiago. That's Alon. That is Jamie. Jonathan is also with us, but he was unable to make it, unfortunately. Yes, we are. So the problem we chose to tackle today was actually the lack of representation and lack of access to different languages around the world. So if you want to learn a language, whether it be French, Japanese, or German, there's plenty of resources online, as well as different languages. However, there are a few languages that are currently dying and have been for the last 200 years. So these include the indigenous languages, absolutely Aboriginal languages. We actually have over 250 Aboriginal languages in Australia. We have plenty of languages in South America, North America, and Africa, which are currently dying. And that is not actually being helped by anything. That was actually expedited today when we were actually trying to research languages to include in our demonstration. We couldn't actually find a word for most of the languages we picked, because it was actually that difficult finding even basic phrases in such languages. So indigenous languages have actually been going extinct in a very rapid pace. I believe over 100 have gone in the last century, and more are to come, as a lot of people don't have anyone to communicate their language of their culture and their ancestors' culture at all to anyone. No one will understand them. So we reached out for community support. I reached out to a Brazilian professor of Tupi, which is a language that had 1 million practitioners, including from where I was born. It was the most practiced language in that time before colonialism, and it was the most practiced 100 years ago before the Brazilian government started trying to destroy it as a means to better unite the country, as we were having issues with revolution at the time. Today, there's only 10,000 people speaking Tupi, and I reached out to a professor of it, and she showed great interest. It is in Portuguese, unfortunately, but she showed great interest in it, and she, unfortunately, she was unable to respond to us as she was outside the country, but she linked to a professor who hasn't gotten back to us, who is actually interested in working or perhaps just helping us with this in general. So Quokka.io is, we're basically just trying to create a tool, perhaps like Kahoot or Ripple if you used it in your classes, where you can create your own resources for languages so you can contribute it, because it is perhaps impossible for a singular team of paid developers to contribute enough resources for a language that maybe only has 5 users. So the hackathon roadmap, we did ideas and concept the first day, functionality the second, integration the third. I'll give Alan the demonstration.
All right, here's the nerve-wracking part. So when we went about designing the interface, we had to keep the mindset of the users in mind, and because we'd have to be interacting with so many people of different backgrounds and different cultures and different knowledge sets, we tried to give it a very simplistic, easy to use and intuitive design. So when you come to the landing page, just a very simple page, and greets you with a create account or login. So we'll go through the login, and just some basic, like if you don't get the right email, it'll tell you. And this is all integrated with a Firebase backend. So once we log in, we're greeted with a learning page, which is curated per the user, per what resources they've already accessed, and what resources they may already be interested in. So we're greeted at the top here by a recommended page, along with some languages and flags to associate those languages with, trending and other resources. And on the side, you can see a create new under my resources, which gives the user access to edit the resources they've already made or create new ones. So just an example, I'll go into the Maori food quiz. And you're greeted with a pretty simple user interface. This is a quiz style question. However, we do have plans to implement stuff like writing tests, as well as audio style questions and more. Does anyone know the word in Maori for bread? See, that's part of the problem. All right. So pretty simple. I won't keep us too much. And then going back, people can continue to interact with the website.
All right. So live demo is done. So a few mistakes that we made during the hackathon. I'm sure lots of people made lots of mistakes. First one was issue with Git. We kind of got lost with lots of different branches, and everyone kind of got confused with what number of branches they're working on. So we just eventually just started sending all our code to main.
That's it.
Okay. That's it. Thank you.
Nice easy question first up. What's the tech stack other than Firebase?
React. as the front end and Firebase as the back.
Hello. So I just have a quick question. So you said at the beginning you found it really hard to find words for languages, because they're so they're disappearing at such a rapid rate. So I just got a question. If you had more time, or envision this as a long-term thing, how would the system help? I guess expose some of those languages to the users. How would a user come to the system and figure out what languages they can sort of find? What kind of metrics would you use for that?
Do you want me to take this one?
I can answer, but
Yeah.
well, perhaps a form feature with good SEO optimization. So just searching up what does this mean in a certain language, or best way to learn indigenous language will show up, which give access. Perhaps also integration to learning systems from a young age to college level, which gives access to pretty much everyone to be able to actually learn it, and gives access to democratization of access to information and knowledge.
Great initiative. What direction would you see it going from here? Would you look at this becoming a focal point and you holding the content and bringing people to your platform? Or do you think you're likely to go in more like a content aggregation path and basically scrape the internet for these resources and allow people to come to you to find them?
I think the idea, I guess, for the future of it was more so kind of a collaboration tool for academics and stuff to kind of use it to almost as an archive as well, all these languages, and just a platform that they can share with. So it would be more so we host the platform and they come to us, we host the kind of their lessons and stuff and share the lessons, and then that's kind of the idea, I guess.
Awesome, thank you.
Cool. Is that everything?
Another question, the reference to all future presenters, when you're answering questions, can you stay in the left hand so we get the audio on the mic?
Oh. Sorry. Great, is that all? Yep. All right.
That's going to be the...
That one.
Alright, next up we have Team Gambrel. Sorry if I said that completely wrong. Up after that is Team IWC, so make sure you're ready.
Okay.
No, they have one.
Okay. Yeah.
Is it going to show up? Alright, so hi, thank you. So we are Team Gambrel, a team of first years. There are 4 of us. I'm Rachel, this is Limal, Duncan, and we also have Lewis in his absence, and we are working on this project called UQLoft. So basically, as a team of first years, we are obviously really into our studies, and we find it really difficult for us to be able to access, I guess, answers to the practice exams that we're studying, we're doing. And obviously there's UQAttic, but the issue with UQAttic is that it's built on a Google Drive that is very old, and it doesn't really have a very good search feature with lots of subjects that are quite obsolete. And also, in terms of finding the solutions, there are quite a few, I guess, spam messages that aren't really relevant to the solutions that are in place. So obviously, we want to fix this.
So our goals coming in, firstly, we wanted to improve the overall user experience. We wanted to make it easier to search for and access papers and their solutions. We also wanted to separate all the spam discussion from the actual solutions. And then finally, we wanted everyone to have the ability to contribute their own answers in an organized way. So yeah, we're basically upgrading the attic into the loft. Yeah. So here are some of our initial ideas. So we've got the home page there. We've got an example course page with all the exams. So if you hop into an exam, this is sort of what it would look like. You've got the PDF viewer on the side. You've got the solutions on the right. And each solution will, each question will have its own like distribution and own discussion board. So that's sort of what we were aiming for over here.
And in terms of, I guess, integrating the data, we've decided to, I guess, try and integrate a database schema so that we're able to access all of the relevant information quite easily, and this makes it really easy to scale up in the future. Also, in terms of the development tools, we'll be using, I guess, React for the front end and Flask for the back end.
So as of this point in time, we have two main demos that we have. One is a user interface, a user experience-based website, which is what we want to match the user experience to as much as possible, and a second one that just demonstrates an additional functionality that we have, and I'll get into that later. So if we click on this link, it'll bring us to the home page, and if we enter a course, let's say CSSE 1001, that should be working.
Type in the URL.
Oh, I think it's just a bit slow. So, as we mentioned before, this is the introduction, and let's say we want to access a random paper, let's say 2019 semester 2. It's going to load up the PDF view of the paper, along with the solutions, and the highlighted solutions are the most popular solutions based on user data. And if you want to access the individual distribution of each question, you just click on this icon, and if you want to access the discussion board, you just click this icon, and these are in development currently. So on to the second demo, which is highlighting this extra function, add paper. So if we want to search up INFS, it doesn't exist in our database, so if we want to add the paper, we just enter the details of the paper. And obviously this will be scrutinized by other users, just to, so you don't add a random paper before it gets submitted to the database. So if we add the new paper, and then we search up the same course code, INFS 1200, it's going to show up, it's going to bring us to the course page, and now we have this PDF that we just uploaded, and just to test the link to the ECP, that's going to exist for all the other course pages. If we click into this link, the PDF is going to load for the question. And if we want to view the solutions, obviously we just uploaded it, so there's no current solutions. So what we can do is the users will submit their answers. And right now, the current interface isn't the best, but this is roughly what it's going to look. It's going to look like our mockups as we were presenting before.
So as always, hindsight 2020. What we learned, maybe we shouldn't have used both React and Flask, since we didn't know what we were doing with either of them. You should have watched YouTube tutorials before the hackathon, not like halfway through the second day. Don't attempt to use INFS knowledge about databases, just use APIs all the way, and get more sleep. But we did learn some really useful things, so version control. So version control, which we had never really dealt with before. Learning about APIs and requests, and obviously Flask and React.js. And finally, just working as a team in coding environment, because we've never really done that before.
That's it?
Yep,
Lovely.
that's fine.
Okay, cool. So you said that you had a big focus on human-centered design. So just wondering, sort of, what kind of did you do any kind of methods to validate your design at any point, or was it just kind of like, I mean, we all agree UI is a little bit outdated. Did you do any sort of research? Did you draw inspiration from other examples on the internet, other applications you've used in the past, or sort of what was the process to get that human-centered design you're talking about?
Yeah, so I guess for that one, I guess more of the focus for that is, I guess, to do with color schemes, having alt text, so if you were to tab all your way through, you'd be able to access everything well. I guess in terms of, further research that we've done, obviously, from using your Google search engine, or even, for example, learn.uq and things like that, we were able to identify exactly what's good and what's bad user experience, just from, our own experience with different websites.
Yeah, great answer.
I like your crowdsourcing answers and building up a database there. Have you thought about any any smarts around how you determine the best answer rather than, I assume you're probably originally using just the number of people who submitted answers for a particular thing. Have you thought about anything a bit smarter around that?
So I guess right now it's just we're just highlighting the most popular answer. But in the future, I guess we could look at how many responses we receive as well. Because say if we've got less than 10 responses, we're not really confident on whether that is the right answer. So maybe we might choose to have that highlighting feature once we have enough responses.
Yeah, I just wanted to add to that. We also, in one of our mockups, we had a view on different accounts. Each user has their own account, and we have an upvoting feature. So if you look at a solution that you like or you think is a very good solution, you can upload it, and we might design a system that will bring that solution to the top of the feed when you open the discussion board.
Really awesome to see that you got it deployed. Is there any reason why the front end ended up on GitHub Pages and the back end ended up on Quokka?
Yeah, so about that one. So as we mentioned in, I guess, our hindsight 2020, integrating our React and Flask was quite difficult, especially since we had very good breadth of knowledge, but in terms of the depth of it and integrating it all together, it was quite difficult. So in the end, we just figured that it was best to show, I guess, the best parts of both sides, and that was, I guess, the way that we found to, I guess, do that. Yeah.
All right, next up we have Team IWC, and after that is the C sharps. As you can see, this is a complete mess to actually run.
One sec. Oh, there we go. One sec. Yeah, you good. Can you make that full screen?
Oh yeah, sure. You present up there.
All right. Hi. So we actually, when we first came here, we had another idea, but then we realized that someone else had already done the exact same thing way better than we did. So we had to do something else. And we thought of this problem, what if there are two friends at a bar, right? And one of them bets they can do something fit 20 pretzels in the mouth. Okay, but their friend is not very trustworthy, so how can they be sure that their friend is going to pay the money? You just can't. So, what if we solve this problem by using cryptocurrency? So you bet 10, you bet say 10 Betcoins that you can do the pretzel thing. Your friend says, oh no, I'll bet you 20 Betcoins that you can't. And you put it into this pool, okay? And you can't access the Betcoins until the bet has been resolved by an adjudicator, which you decide upon, say the bartender. And all of this stuff is on a real blockchain. It's immutable, it can't be changed. Anyone can see that your friend made the bet, and if he doesn't pay up, well, that's literally impossible. So, that's that. We will do a...
Oh.
Yeah, okay.
Quickly, I'll explain how a bit of the blockchain, very rough. So we host a smart contract on Ethereum. We host our own token that can only be betted. It can't be traded, it can only be betted. It's global, everyone can see, it's public, all the things are viewable by a third party if you wanted to make a client. We're going to have a live demo, good luck.
Oh yeah. Damn, okay. So I guess we can just we also did user accounts. So you can log in. I think that'll make sense in a second why that's necessary. Awesome. So your user accounts, your money is as safe as your password, and all the accounts here have a password of password. So that's pretty cool. So here's sort of a sample account I made. So you can see your balance in Betcoins and Betcoins, and it's got all the blockchain data there as well. These here are like your friends. So the way friendship works is like, so for cryptocurrency transactions, everything is relative to like keys and IDs. So what we did is we made a database of like all your friends, right? Because that's like the problem domain of like betting with people you know, of mappings to like people's names and emails to their like crypto ID or address. Yeah, so what I've done here is I've got 3 accounts, Will, Isaac, John, I don't know, something. Yeah, we've got these different accounts. So for instance, here, yeah, Isaac has bet me that he'll beat me in Minecraft. So he's bet 20 Betcoins and he wants me to pay 15 for that. So I can either accept or decline it.
Of course I'm going to win.
So yeah, that's rubbish. So I'm going to accept it. And like that doesn't do anything, you got to refresh it, but like proof of concept. So what happens is both of our money like goes into what we've called a vault. So I just forfeited 15 Betcoins, and on Isaac's account, like, yeah, so that's what it was before, and he should have like 20 less, so it should be like 70 or something. Yeah, okay. So none of us can access that money at the moment.
Adjudicate the bet, yeah?
Yeah, who's the judge? I forgot.
I think
It's probably Will, hey.
With the third person.
Oh yeah, cool. So like I won, for instance. So, oops.
Whose is that?
I think it's Will. Yeah.
Try the other account. Carson's account.
No, that's not right.
No.
Password. Yeah. So, Carson won. Oh, maybe we. Yeah.
Yeah, I'll log into Carson's account.
It does work, I promise. It's there, like it hasn't gone away, it is, yeah.
Alright,
Isaac. Validate Isaac.
Log into
Go
Isaac.
back into that one
That one.
and sign in.
So that's
and
Will's account, yeah?
Isaac.
Validate Isaac. Oh. Yeah. Okay. Okay.
Okay.
Yeah. So I don't get my money back, but like Isaac won. He probably put that in there like right before. Yeah, so.
I love that demo. It's the perfect example of a stealth hackathon demo. Like, great work, guys. One thing that I found interesting there is you had all the different accounts open in browser with the same browser. How are you managing the different accounts without using cookies or something?
It's just all in React State, so you gotta log in each time, but it's secure, so.
From the browser itself, you can access with Ether.js to access the blockchain itself. So it's no backend is required to actually access the blockchain, only for the name to key database.
Yeah, like we just have a database of users, and then with each user is associated the private key, and then from that you can access their balance.
So I guess my question is really, so like what if I made a bet, right? And then we both kind of agreed to back out of it. Like what if I bet, like Taylor here, that I reckon I can drive my car into the lakes, and right before we do it, I'm like, I don't want to do this anymore. We both agree it's not a good thing. Is there any way I can back out of the bet?
Yes.
It's not in the front end yet, but it is in the contract in the blockchain, so you can back it out, or the adjudicator can decide to split it evenly.
And if the adjudicator decides not to adjudicate, then everything just gets returned.
Oh, nice. So literally all bets are off. Oh, fantastic concept. I mean, Australians are great punters. My question is, how do you cash out?
How do you
get your money out?
We could make a centralized system for it, but at the moment, like, there's not really. It would be the same way as in any other cryptocurrency. So someone would probably have to set up some like rigged system with a bet,
to transfer money across because there's actually like no way to.
On purpose.
Yeah, they'd have to like intentionally rig a bet and like set up the parties to transfer money because betting is the only way to transfer money between accounts. So they could.
So currently it's a closed system.
Yes.
Yeah. So they could probably like rig some system to transfer your money from your account to some centralized account, and then they'll give you real money back.
All right, thanks very much. Awesome.
Awesome, thank you.
All right, group 4, we have the C#. Followed by that, we also have the Gameboys, so just be ready to present.
What the fuck is the Hershey whiteboard on this thing?
Do you want me to? I can get you step through. Yeah, probably.
Cool.
Be closer to the mic so we can hear you.
Cool. Hello. Awesome. Hi, my name is Tremaine, and this is David. We're both QUT students. Sorry. Aside from being a student, I also am a pharmacist as well. So I did pharmacy in a past life, and something that has been an issue throughout my time as a student pharmacist, an intern, and now fully registered is dealing with shortages. There's often a lag time between doctors being aware of shortages as well as patients being aware of shortages. So patients are running around trying to find a drug that is actually unavailable. So they're wasting time calling pharmacies. Doctors are wasting patients' time by prescribing drugs that they can't even get. So the solution, well, just give people and doctors and other health professionals a way to check shortages and look for potential solutions. Sounds pretty easy, right? There is a database that the TGA provides, but it's pretty rudimentary. You'd think there would be a nice API that proprietary software developers might be able to use, but no, there's really nothing. You're basically relying on this horrible...
There's a spreadsheet.
Yeah, there's a spreadsheet, yeah. They give you a spreadsheet that you can download in CSV format, which as we know, everyone loves CSV. So David and I have basically come up with a solution that uses the fairly terrible options available to us and hopefully makes something a bit more useful for doctors and patients to use. Ideally more searchable to check shortages, as well as provide solutions to those shortages. So check for alternative products, and actually make sure those products are available in pharmacies as well. So
we'll stop talking about it, we'll actually show you it working. So, this is the home screen, so just loaded it up. It's, first of all, it's loaded all of the, so from that CSV, we've now got it, parsed it, put it in our own database, which has its own,
Technical difficulties.
Goody. Okay, there we go, cool. So, this is the landing screen. We have in the table here, this is the data from that CSV that we have pulled, parsed, put in our database, now exposed with our own API. So in theory, you could hit it and we could give you this information if you wanted to use it. These are all of the national shortages recognized by the TGA rather, the ARTG, confusing. So one of the other features, I can search through here. So I can come through and search, I know that Zoloft is one of the drugs that's in shortage. However, there are possibly substitutes for it. So we haven't just got the data and put it in a pretty table. One of the really important features here to address the shortages issue is that we can recommend substitutes based on their active pharmaceutical ingredient. So I can select this one, it's the one drug, and I'll ask it to find some substitutes. and it's found 33 potential substitutes based on the active ingredients, and these ones are not in national shortage. Scroll through here and you can see all the different types. This is where domain knowledge comes in. So you, as an end user, unless you're a doctor or a pharmacist, you're not going to be prescribing yourself your own drugs. Just because they're potential substitutes doesn't mean they're actually valid and can be used. It's up to the doctor to prescribe that for you, but at least they can check. So, for instance, we can see that this sertraline Sandoz variant with sertraline hydrochloride as the active ingredient, not in shortage. We can check for local pharmacies that have it in stock, and it will bring up a map. And we can see there's 2 pharmacies that are registered with our application. This is dummy data, just FYI. We haven't used the hackathon time to go around calling pharmacists and say, hey, register with our app. This is data that we've put into it, but using our API and showing that it would be there and searchable. Apart from that, the other big benefit is just the usability over what currently exists. So you've got to come through here, and if you even did something like, you can see paroxetine hydrochloride is one of the things that's in shortage. If I start typing hydrochloride, it's like, no, there's nothing in shortage with that. And it's like, oh, okay, cool. Which is clearly not the case. However, if I go here, well, anyway, you can see that it works and the searching's better. Open it up for questions now.
Obviously, patients can use it to sort of get an idea, but it's mainly the doctors because, as you said, the domain knowledge is important there. How do you intend on going around and connecting pharmacies? So you were saying that you didn't have time to call up pharmacies, and fair enough, right? But what would be your intention if you had 10 more years of developers, for example? How would you go ahead and get pharmacies onto the system? What would be the plan there?
Yeah, that's a good question. It's a bit hard because all pharmacies use different stock systems. They usually, the developers of those systems are usually pretty good with opening them up to other, forms of software, opening that up. So it'd just have to be a matter of liaising with the developers. And then pharmacies would have to be okay with, what drugs they actually say they have in stock, because not all pharmacies are going to be okay with saying certain drugs are in stock for various reasons. So yeah, have to deal with that. We are hoping to also make it more geared towards patients as well. Ideally, patients could, record what brands they prefer or just generally what drugs they're on, and they can potentially get a ping when something is short as well. But yeah, I guess at this stage we've just focused on more the health professional aspect of it. So yeah.
You mentioned the difficulty in getting this data out of the TGA. What's the lag between the TGA becoming aware of a shortage and you being able to update the system?
Yeah, that's another really good question. So there is legislation in place. There's mandatory reporting for drug sponsors. They have to report when drugs become short, and even if they anticipate a shortage for whatever reason. So I couldn't give you an exact number as to how long it takes from them becoming aware to them actually updating the database, but there's not too much of a lag. It's not too bad in my experience. I couldn't give you a solid number though, unfortunately.
You can see in the table already that there is data that is, their status is anticipated, so it's not a current shortage, but it's coming up, and that's already in that table.
So that Zoloft example is a good one. But that seemed like a pretty clear case of generic versus a branded medication. When it comes to making the app more patient-facing, how would that come into play when it's not a simple matter of a generic versus a branded substitution?
Yeah, that's another hard one. I mean, ideally you would not, from a patient perspective, I'm not too sure. From a health professional perspective, you'd want to be able to not just see generic substitutions, but actual class substitutions. So sertraline was short across the board. You'd ideally like to see other SSRIs, so escitalopram or something like that. But again, like, we would have had to manually classify each drug, and that'd, yeah, take the whole weekend on top of doing all of this. So whether or not patients need to know that, I suppose they're absolutely entitled to know that. So yeah, you just have to make sure you present that information in a way that's more suitable to patients. Not everyone's going to know what SSRI means, but that is something that crossed my mind. It's just, yeah, we just had to work with the way the data was presented, unfortunately.
Thanks very much.
Thank you.
All right, next up we have the Gameboys, followed by Team Sheeeeesh.
Do you know if the HDMI has sound? Let's see.
We can make it should work actually. Give it a go.
Got no control over the volume. Right, let's see if this works.
Nope.
It wasn't humanly possible. But now you can have all the power and excitement of Nintendo right in the palm of your hand. Introducing Game Boy. It's portable, it's in stereo, and its games are interchangeable. Plus, Game Boy comes with the outrageous new game, Tetris. And for head-to-head competition, use the revolutionary video link and blow your opponent away. Game Boy, only from Nintendo. Now you're playing with power, portable power.
All right, good afternoon. My name is Levi, and this is Campbell over here, and we have decided to make a Game Boy game in C. So our project is a 2D version, top-down Rocket League, playing on the original Game Boy. So Game Boy's a pretty old system. It's over 30 years old, and the games, I think back in the day, the games were programmed in assembly, but now we've got a very helpful development kit which sort of manages the sprites and the console input output. So we can program it in C and a little bit of assembly. And then this runs in either a Game Boy emulator or on the actual hardware. But this hardware is pretty limited with a very, very primitive processor. It only runs a bit over 4 megahertz. It's only got 4 colors on the screen and got 160 by 144 pixels. So you can't fit much on the screen at one time, and hardly any RAM or VRAM. So you can't even fit all the different tiles on the same screen at once. And also the CPU can't do any floating point, no real math problems. So for a physics-based game like Rocket League, it makes it a little bit difficult to do physics calculations.
So some of the issues we encountered were obviously, as Levi said, the physics of it all, since there's no real foundation or any physics framework we could have used to calculate the velocity and the acceleration. So we had to build all that from scratch with our own methods. And obviously not being able to rotate the sprites properly, having to have like a direction variable and control which sprite is being displayed on the screen at one time. And also just many, many problems with memory, and C in general being very taxing to use, very stressful. So, and how we compensated for those errors. We created sprites, as I said, for the 16 different directions. And we had to figure out a way to implement collisions without floating point math. So that means we times everything by 100 and did everything with integers instead. Dynamically loading the sprites in the background, deflections on the direction of the ball, and we even implemented a simple AI at the very end, which was not very sophisticated, but it was fun to play with. In the future, we probably want to extend the AI a bit and maybe have even local multiplayer with the Game Boy link cable. Bit more animation in the game would be nice. And yeah, fixing a lot of bugs, because right now it's not very reliable, but I mean, it's playable and that's all that really matters. So yeah. And now Levi's got a bit of a live demo for you.
All right. I'm hoping we can get this camera
We
set
can't
up.
get that, we can get that camera. So we
That
can
camera?
get
All right,
you on
cool.
the big screen.
Yeah. Let me see. Can I come around to this side?
There we go.
All right. The focus is probably going to be. This is not good.
Hold on. This is.
Okay. Is it going to focus at all? I don't know if it's got like. It might be set to focus.
It's probably just really badly focused.
All right.
Also probably long lens.
Oh, I don't know if I'm actually going to see anything at all.
It's alright. I can confirm it is running on the Game Boy.
Well, would the judges like to have a play? And meanwhile, for everyone else, I'll get it running on the emulator so you can see it on that. Yeah, cool, thanks. Now, this has got our buggy AI, which sometimes hits the balls out of the screen. So you just have to sort of get it back. And, oh, it's got a go. That's nice. So the AI is a bit of a pain. But, you know, hopefully we've got some bug fixes on the way. But that's all. So thank you very much.
So obviously the game was super resource constrained, not just the CPU capabilities. But did you have any issues with the compiled code size or like resources including sprites? Or did that turn out to be okay?
No, it was pretty okay because I think in total we had about 150 sort of tiles that are all 16 by 16, and I think the most it can do is about I think it's 256 or something like that. So, I mean, our game's pretty light compared to like Pokemon on the Game Boys or something. We've hardly got any sprites compared to that, so we actually didn't have too many problems with keeping it all within the size constraints. Good.
So, what was the biggest takeaway, I guess, from taking a game like Rocket League and shrinking it down to a handheld console from 1989? What kind of sacrifices did you have to make in terms of the game design to sort of make it feel fun? You said you were having some, you were actually enjoying it by the end of it.
Yeah. So originally we wanted our field to sort of have like some angles so the ball could do better, but that would require a lot more sort of mapping as to. Because the ball's got 16 directions, and when it hits a wall, we sort of map that to a different direction that comes off. But when we've got the angle, it really changes that a lot because we tried to get collisions based on like an actual tile basis rather than just an X and Y coordinate. And was there another part to that question? Sorry, is that
basically sort of So I mean, like, what sacrifices did you have to consciously make to make Rocket League work on a game?
Yeah.
Like, you seem to be fans of the original game, right? So how did you maintain the spirit of Rocket League?
So obviously, you can't jump up in the air, but like the real fun is just sort of having the ball and the car feeling right when you hit the ball. So being able to, when the ball hits the car, to sort of, you've got to slow down the car, speed up the ball, and you've got to, it was hard with the Game Boy to like sort of, sum up. We couldn't really do vector math because we didn't have like trig functions or nice floating point math. So it was sort of all like, how do we lock everything to a grid without it really feeling like it's being locked to a grid? And so that was like the real challenge, to get it to feel right, feel sort of free when it's all really just locked to a grid. So. Okay.
I think you actually answered my question, which was how did you actually handle the trig functions?
we didn't.
We were seeing the demo there, and I'd encourage other people to have a look at it if you want to. You did nail that. It was very well done. So that actual feeling of when the car hits the ball and it's like there is momentum there. So you want to go to multiplayer after this? That sounds like it's going to be a whole lot of fun.
Yeah, we'll have to use all our socket knowledge and multi-threading. We both did in a course last semester. I was hoping I wouldn't have to touch that stuff again in C because it was a big headache. But at the same time, I think it'd be fun to really apply that. So yeah, we'll see how it goes. I haven't actually seen any documentation for any sort of link cable socket stuff. But it'd be a cool learning experience to take it even further. Yeah.
So how do you actually get the game on the Game Boy?
Yeah, so the GBDK software development kit sort of has its own compiler, and that compiles it down to a GB ROM. And so on the Game Boy, I've got like a flash cartridge with an SD card, so you can just put the ROM on that, boot it off that, or you can boot it onto an emulator. So yeah, it was getting a compiler to compile that C to an actual ROM. Cool. All right, thank you.
All right, next up we have team, I'm not even going to say it because apparently I got the meme wrong. So, and next team after that is myself and me.
What do I plug in? How do I do this? This into this?
Yep.
All right. Now what?
Hope it works. There we go.
When do I start? Hello? Testing? All right. Hey everyone, we are Team Sheeeeeesh! And this weekend we built an educational gamified recycling mobile app called binnit. Now that's a lot of buzzwords, but like I assure you, man, we did it. So here's our team. I'm not going to go talk about this too much for the sake of time. This is all for all of us. Our final hackathon. We're going to be graduating and out of uni next year. So full screen?
Yeah, why not?
Sorry. So we wanted to tackle a very ambitious interdisciplinary project. So I'll walk you through our weekend goals. We wanted to make an app that could educate individuals on the correct ways of recycling, encourage others to recycle in a fun and competitive way, hence gamification, and just a YOLO, we just want to investigate beneficial real-world applications of machine learning. So I guess with hackathons, you'd want to get your core functionality down, so you have a pretty robust app to show. So what we wanted to accomplish this weekend was 4 things. So waste image recognition, so we upload a photo of waste and we'll have a machine learning model on our backend identify what materials were involved. It'll send down the material rundown and you'll get points associated with how many things you have snapped, and it'll give you a breakdown about how and where you can recycle them, if they're even recyclable, and a bit more information about the material. On the gamification side of things, we made user profiles so you can see how much you've cleaned up over a series of different timestamps, your breakdowns and all that, and nothing gets people going like a bit of competition, so we have leaderboards to see how much waste everyone else has picked up. So our tech stack, we got 4 core technologies: React Native, just our framework for mobile app development; Firebase, easy to use APIs for storage and sign-on, as well as other things. Really great for rapid prototyping and hackathons. And our backend was made in Python because PyTorch is in Python, and I don't want to make a machine learning service and a node service to talk to it. So that's what we got in our backend. So this sounds really cool and interesting, but what does it look like? How does it work? So we have a live demo. Like, we got our app working, but it's a bit scuffed because the way we're doing it is we're sharing screens on Messenger, and Liam in the corner is going to give a live demo of our app. And Dennis will run you through it.
Hey everyone, so this is just our sign-in/sign-up screen. So if Liam can just create a new user, and we'll just start from a fresh profile. So usernames, emails, passwords, just your basic stuff. Sheesh. Yep, so here's our profile. So at the moment, it's obviously blank because it's new. So we'll just start with the leaderboards for now. Yep, so we've got the leaderboards, so we've got the top 10, so you have your rank, your name, and then the points. So we can sort by date, so we've got 3 filters, daily, weekly, and monthly. So how do you get these points? So if we just go to the main camera function in the middle, yep, so here we have a little preset over there, so if you just take that picture, and it'll just send it to the back end, do some cool stuff, and magic. So we've got our quick point summary, so it's found 4 pieces of metal, cardboard, and paper for a total of 600 points. So we can click on that, and so here we've got the boxes of what the machine learning model has showed and recognized. So when you click on one of those boxes, it'll bring up information on kind of what you can do. So with metal, it's recyclable, you know, good for the environment. If you recycle it, very cool. So now that we've done that, when we go back and we go to our profile, yep, it'll update. So now it's got our new totals. So you've got 600 points. That's really cool. And, you know, add more points and you can get on the leaderboard. You know, good stuff.
Good stuff. So on to the last slide is limitations and future opportunities. So with something like this, it's very easily spoofed. You know, you can take a billion photos of the same thing and then just rack up your points. I have thought about ways to get around this with accessing image metadata and, you know, really locking down the phone application such that we can't really send fake photos from a file directory. And, you know, like with hashing and all that, we can make sure that no 2 photos are sent. We also want model accuracy, you know, that we only had a weekend to train it. So here's a bunch of future opportunities, but the one I want to talk about the most, it's on 20 seconds, is point redemption via third-party integration. The thing is, this app is useless if you can't use the points. So what if we could use the points to redeem Kohl's vouchers or Woolies vouchers, or have tournaments in between your company to see who can like recycle the most. And all this other stuff I'd like to talk about, but we're out of time.
So some really fast image recognition there. You said you only had the weekend to train the engine. What did you train it on?
So yeah, the algorithm we used was YOLO v5, and I actually made the entire data set myself over the weekend, which was an interesting experience. I had a lot of fun ripping trash out of my bin, throwing it around my apartment, and walking around, taking photos of it, and then monotonously sitting there and labeling every single photo and training it on my GPU. But it works pretty well. Obviously, you know, the art of the demo is still there a little bit. So, you know, if you take a photo of something and there's a lot of other stuff around, or you take it in an environment that, you know, I didn't train the model on, it might not perform as well. But we can just pretend that it works perfectly every single time.
So you have points associated with, like, you know, the different materials, whatever. I've kind of got like 2 questions. One, does the size of material ever come to play with it? Like, would you expect, like, if I had like a giant comically sized can, would that be worth more points than like a tiny can? And the second question is basically, what happens with composite material? So for example, the classic example of recycling is the coffee cup, right? So you can recycle the lid, you can't recycle the cup itself because it's like paper and glue and stuff. So what would you expect in the future to sort of handle those kinds of weird material edge cases?
So in terms of composite materials, you know, you could obviously train the model to recognize this part is the lid and this part is the cup. This lid is not recyclable, and we have a waste category, and waste category just means, you know, we're going to tell you to throw it in the bin and it's going to go to landfill. So that's one way to solve that problem. And then, you know, given that we know the size of the bounding box that's being shown, you could use that information to infer that this is a comically sized can, but at the same time, someone could just get really close to the can, scan it, and then you have a massive bounding box. So I think that's like a harder thing to solve, but, you know, if you throw a model at it for long enough, I'm sure it'll be able to figure something out. So there's potential for that down the line as well.
I also have 2 questions. First one is, if you take a selfie, does it label you as trash?
Yes.
Good to know. Second, a lot of different municipalities will have things that you can recycle that others won't have. Have you considered that in models at all?
In the actual models, no, and it was one of the limitations, I think, of the app that we definitely thought about, was the fact that, like, we haven't necessarily made this app it's not localized. And so in different countries, they're also going to have different rules about recycling and that sort of thing. And so again, this is something that you might be able to solve with the help of not necessarily the model itself, but just like a user's geolocation data or something like that. And you'd be able to be like, oh, you're from this place, or we have another model that's specifically going to do inferencing based on your location in the US and stuff like that. So.
Alright, up next is myself, and me, and followed by the final one of the group one will be not implemented error.
Alright, yep. Hello, my name is Daniel, and today what I've been working on is what I've created with a very basic statistical tool. Essentially what it's designed to do is it takes a host of variables and it compares them all against each other. And it's fairly straightforward, but the hope of this is when you have people who don't know anything about data science, who don't program, so essentially the polar opposite of us, when I've seen them do data entry and analysis, what they tend to do is they pluck a variable out that they think is interesting or looks important on the data. And this is designed to essentially do that for every variable simultaneously and to do a few basic statistical tests on all of them at once. So it takes in a large amount of raw data. We use the wine quality data set because we know there's liable to be some correlations simply because it's in the machine learning repository, so it would be interesting. Essentially, the biggest issue I had here was there was only one type of variable in this actual data set, which caused some issues when I tried to import other data sets, and that's going to have to be fixed at some later point. But it takes in all the data from the data sets and separates all the variables. It then does a host of tests on the variables, as you can see here, and that essentially has a tag so at the very end of that. I'm not sure how to get the mouse up, just over there. Essentially what the tag does is it flags all the ones that are potentially relevant in the first analysis. It doesn't actually have in the graph the tests that are used to determine whether something is statistically significant or not. That's done under the hood, but in the graph that actually comes up for the person, it flags all these ones. And then, I don't think this was done particularly neatly, but what I did is I erased all the ones that were relevant, so it simply comes up with the statistics that are potentially relevant on the screen. So a person who has no idea what they're doing can just look at this, see two variables that they're interested in, say, okay, there maybe is something here, maybe isn't, and then they know where to look into. So that's all there is. It's not particularly sophisticated, but I thought it would be potentially useful, and I know that when I was mucking around with text analysis, I wished I had a tool better than this, bit of this nature essentially, so I could actually see what was going on before I started doing individual tests. Problem-wise, when I was creating it, I hate pandas, and I always will. And when I realized that this is only going to work for discrete continuous variables, when we start introducing other variables such as ordinal variables and categorical variables, it's going to not only need to accept the variables, it's going to need to have a formula at the start to actually run a different set of tests. And that's all there is. Sorry, my apologies. I've created a couple of graphs on the back of it, but this is just fairly straightforward programming. The second set of graphs, the second graph at the bottom right, isn't particularly useful in a statistical sense, because all it's doing is comparing all the statistics against each other. What it actually does, however, is it basically shows you can compare the statistics, they do exist, and then if you and essentially, because you can look at them against each other, the hope would be you can use them in some sort of future modeling. So if you want to test a second layer or a third layer deep, then you can use those numbers in some way, shape, or form. On this data set, it's worthless. And that's it.
Have you put any consideration into the performance of this tool as you scale up to more and more variables? Because obviously you're testing pairs and variables against each other. So.
It's a fairly high cost test, but because it's essentially designed for non-data science users, so it's designed to be in relatively small data sets. The reality is when you have a data set that's going to have more than 10,000, 100,000 entries, you're not going to need a token tool such as this. The tool is designed to work on relatively small sets and essentially home projects in which it's not going to have a high cost.
So you said the intended audience for this tool basically was for people who aren't really into data science stuff, people who are sort of entering that kind of, this is their first foray into statistical stuff, right? Have you given any consideration to, if you have more time maybe, to like work on maybe visually representing the data a bit nicer? You know, maybe putting it like, so from what I saw basically, the presentation for someone who maybe wasn't super well versed with statistics would still be quite intimidating. You know, they have their data sheet, whatever, and it still looks quite, you know, statisticky. So have you considered, you know, maybe if you had more time, would you have looked into that? You know, maybe made it a little bit more user-friendly in that sense?
Absolutely. It was actually one of the biggest issues that I encountered, which is when you have that vast body of statistics, how do you pluck out the individual ones to make it easily accessible as opposed to actually still leaving a lot of information in? Ultimately, I decided to make it bulky because the biggest issue that they often come across is we take information away from them because it becomes unusable, it becomes an utterly unwieldy tool. But that creates the opposite effect for the person wants, that the person can't ever get into the data science side of things because they never get to see anything, they just get what's given to them.
Slight follow-on question, I think. I agree completely that this is a very valid area of research. What would be next? So if you're presenting this to a non-data scientist and you're giving them basically a curated list of the variables from the source data, what would be the next piece of guidance that you would build into this tool to take them down the path?
The next piece of the guidance that I'd put into them is I'd probably have links to some sort of description of what each of the tests actually is and where to go from them. Because these tests are ultimately, they're done broadly, there's been nothing done to optimize them or anything like that, and they're done in the broadest of parameters to get very basic correlations. So what you'd need is a link to something actually telling them what the test is doing, so the person can then do, and what tests are similar to them and can follow on with them, so the person can do their own independent research.
Why the pandas hate?
Oh, I spent 6 hours doing it in the middle of the night and couldn't do it.
Good answer. Thank you very much.
Alright, finally for group 1, we have not implemented error.
Hello, hello, Hackathon. This is Not Implemented Error. My name is Tabo.
Mark.
I'm Ahmed.
I'm Karen. I'm Jack.
Now please remember the name because Not Implemented Error is going to be quite prophetic. Yeah, ironic, prophetic, what have you. So, who are we? We are a team of 5 first-year students from engineering, computer science, the whole shebang. Oh, sorry, thank you. Continuing on, we are first-timers. This is our first time here. We have no idea what we're doing. We've only been kind of helped out by gracious hosts. And what we're trying to do here is create something that's quite ambitious for inexperienced minds. Now, our idea was to build Hackathon the Experience, the game. We looked around, we saw our lovely hosts here doing a really tough job, and we thought, listen, let's try and make sure we can implement something like this in a state-of-the-art simulator. We did all the research on the field.
We saw what you were doing, what you were eating, what you were wearing. It was very important. Don't be creeped out. Now, our problems arose, well, let's say this. Part of what we were doing was trying to create the team into the forming and growing stages. We found, end of the day, building the game itself was a really big challenge, but also the interpersonal troubles we kind of had to face by being a new team were also really, really important. Now, the image that we had in our head was really difficult to kind of bring together because at the first, I guess, couple of hours, we had 9 people in our group. 7?
7, yes.
Yeah, we didn't listen to our host who said stick to a maximum of 5 people. We tried 7, we were totally wrong, so that's for next time. Next. Part of the process was we then decided to sit down, do what we're taught in Eng 1100, and think about ideas, think about our strengths, think about our weaknesses, what we can all provide to the table in terms of our past history and what we want to do going forward. We then took to the whiteboard, decided, okay, this is the kind of game we'd like to build, this is the kind of simulation we'd like to run, and this is how it should maybe look, without really understanding that being, 5 first-year students, we have no idea what we're doing. And to try and do this in one weekend when some of us have different things to go do is going to be impossible. So, yeah.
Moving on to the tools. So, as first years, we weren't very versed in any programming languages. Most of us only knew the basics of Python. But we wanted to make a game, so we needed to make it in a game engine. And we also had to use Git and learn how to version control. So we had to learn GitHub, Godot, which is the game engine we use. We also dabbled in PyCharm, Unity, and VS Code. Now, to say we were ambitious might be a little bit of an understatement. We quickly realized this was too large and stuck to GitHub and Godot. This was a bit of a contentious decision as team members really wanted to use things like Unity and VS Code, and people chose to use Git, and I personally chose to use Git Desktop. So there was lots of varying paths chosen. Our team was quite eager to code. So instead of learning the tools and really grasping a solid understanding before moving on, we were like, okay guys, let's blast ahead. Let's get out there, put something, write something, and move on from there. This was a poor decision in hindsight. We didn't actually create anything worthwhile. We made lots of mistakes that came back to bite us. Now, the real tools are the people. So the product, what we actually made. So like I said, our past failures came back to bite us. We made errors like, for example, we had sprites, we made nodes for those sprites, which isn't something we should have really done. We should have just made the entity by itself with the sprite. We've written code that was poor. People had learned different tutorials and had different understandings of the how to use Godot, and that clashed, and we tried to combine it. There was also our lack of understanding of Git meant we had lots of implementation errors, so we'd have versions conflicting with other versions, and it was a real headache to get around this. So we had to move back, delete code repositories, and re-download them and things like that. Ultimately, we failed. We weren't able to produce the game we wanted, but we had a blast of time trying. Just to quickly, final learnings. Teamwork is key. Know your strengths and weaknesses. Learn your tools before you start using them. And ultimately, it's about the friends you made along the way. I'd like to thank people who panelists of Hackathon for giving us this experience and letting us, try and fail. It was fun. Thank you.
I kind of want to understand a little bit more. What was the intention about the game engine choice? So you see, we wanted to make a curriculum, whatever. And you have a couple of options there. So run me through kind of why some people wanted Unity while some people wanted Godot.
So I was the only one who knew how to code in C# and Unity, and I was the one who wanted Unity. So I'm up here speaking about it.
Yeah, but everyone else only knew like Python and Chen you'd C, but like C's not really an option unless you're going to build your own physics engine. Yeah, so that was the contention, and yeah, it wasn't.
No.
All right. Next question.
No. Like, we could have used Unity because since none of us knew but him, but we were had a lot of emotions during the first day of hackathon. The problem was that when we downloaded Unity, we looked through like the terms and conditions. We found that we can only have 3 people to collaborate, and that was really annoying because we had 7 people at the time. Godot was free, so we could link it to GitHub and stuff, but we were stupid, and we should have just used Unity and just put it through GitHub instead. Like, just don't use Unity's own cloud service. So, yeah, we should have done that instead. But whatever.
So what happened to the other 2 members?
One of our members, his name is Jay, he would have been here, but he slept in today. So that's why he isn't here.
He's sleeping.
Yeah, he's asleep right now. To say we were a team of 7 is a little bit of a white lie. We're actually, 9 at the beginning, then we became 8, but that team of 8 was, fluctuating. People left and people arrived. Like, for example, on Saturday, I left to do some uni work and came back 3 hours later. So, put simply, other team members who aren't here, they had other commitments. And they couldn't fully commit to Hackathon. Not all of us could, but we tried to put in the time we could. And, yeah.
Thanks for coming up here and presenting, even though you didn't end up coming up with something. It's actually a really great thing to see that you're willing to just come here and stand here proud of what you did this year, however little that may be. But my question's a really simple one. Did you guys have a great time this weekend? Did you get something out of it?
Yes.
Alright, I'm very glad to hear that. Thank you.
Alright, just a quick shout out to NotImplementedError. They've put a real lot of effort in. We've tried to help them a bit, and hopefully they still had a great weekend, and we're more than happy to have this on, and we'll definitely keep doing this for the foreseeable future. So, now, of course, we're not without the lovely UQCS jazz band. If you weren't aware, we do have our own jazz band, and it is called Dijkstra's Algorithms. And they're going to play another set for intermission. We're going to have 15 minutes of intermission, so refresh yourself, go for a walk, go to the toilet, have a drink, and we'll be back in 15 minutes. Take it away.
I'm just wondering.
Yep.
So we're going to just do presentations until 6:30, right? And there's going to be like announcement of the winner. Like, how many groups?
There are 16.
Oh, 16? Yeah. Oh, wow. So this is, like, we're done with first, right?
Yes, this is the first set.
Not
That's Droogs. It's with that top.
Alright, let's get going so we can get through these and have some food. Alright, just noting here that is it DaVinci Simulator it's not presenting? Yeah, DaVinci Simulator will not be presenting unfortunately, so there's only 7 groups this time. So we're going to kick it off with Droogs. Give me a round of applause.
Can we open this in full screen, please? What do you need? I want that in full screen because I can't read this. Sorry, I got it.
Thanks. Alright, sorry about that everyone. Thank you for being here. Our team for the hackathon was James, Yash, Chase, Bob, who is working from home, and me, who's Connor. And we're here to present to you WikiTrivia. Already our project has received such praises from passers-by as being scuffed or wish.com Kahoot. So the concept of WikiTrivia is a multiplayer trivia game where the questions are randomly generated on command during the game. So no longer do you need to worry about laboriously thinking of and writing down countless trivia questions. You can just enjoy the game. As you probably know, Wikipedia is vast. To make things a little easier, you can pull questions from a series of lists, which themselves are Wikipedia articles, to get an enjoyable game of trivia. These lists include the top annually viewed pages, the weekly 5,000 most viewed pages, top 100 books, top grossing films, and we're working on top grossing animes and the totally random function, which pulls from all Wikipedia. So question selection will select a random page from the selected list, and then the title of that page will form the answer to the question. The program will check the title to make sure it can make a decent question out of it, and then the summary of the Wikipedia document is used to create the question. These are then presented in a style of the fill-in-the-blanks question. We use a little bit of basic language processing to remove all mentions of the answer from the question. That includes similar spellings or pronunciation suggestions, or things that would otherwise spoil the answer. And that is, it does this most of the time. Generating false answers was something we generally underestimated, but the project uses the Google Trends API to generate other plausible solutions to a question by gathering related search topics. If we're unable to come up with sufficient alternate answers, the question will be discarded and we'll create a new question. As an extra feature, there's now a 1 in 4 chance that the correct answer accidentally gets overwritten by one of the wrong answers, which is great. So that was the back end of it. We do have a front end, and what better way to demonstrate than to just show you. And just so you know, this is random. We don't know what's going to come up now, but it is pulling from the top 5,000 pages, so it should be pretty tame.
Hey, so we have like a question generator engine, and then we have a Flask server which interfaces with it. So that's running here. We actually have a game going already. Sorry. Nope.
It's dead.
I've killed it.
Technical difficulties as usual.
Yeah.
Oh, what could possibly?
There we go.
Hey!
Hey, so yeah, we have a server running there. Reasons not to use Linux. Yeah, so we have a game going there. So when you want to join, you get taken to this page. So you can put in a name, which is your player name, and a room ID. If you click create, it'll create a lobby, and then other users can put in their name and the room ID to join afterwards. So we've got a game going already. So obviously, this one actually, because the answer is obviously Chris Martin,
So Christopher, Anthony, John, it's sort of just pulled out Chris, but not Turfer. So we'll just click that. So you can go here and choose the question list. So the goal would be eventually to have it such that you can just put in like a Wikipedia category list, and it will just generate stuff. But just because we're still building it, it's just like this at the moment. So weekly 5,000. When you click end round, you'll see on the server. Should have gotten the request. Famous lost words. There we go. So it's trying to get generate a question on SARS-CoV. Name's too long. Now it's doing Newfoundland and Labrador. Now James Corden. And there we go. So yeah, so it's generated a question and then like a real answer and 3 fake answers. Does anyone have an answer for this?
You just told them. It's told us.
Oh, did I? Yeah, I did.
Start a new one.
It's carpool karaoke, Jimmy Fallon. So let's do another one. So yeah, it does take a while. There's 2 wrappers there, so one for trends and then one for Wikipedia, so we're a bit dependent on how long they take to load. And then obviously our heuristics on checking questions. So it's done Noam Chomsky. Oh, I told you the answer again, actually. You get some really funny answers. So if we change lists again, we can go to top annual again. Yeah.
Alright. Thank you.
Yeah, thank you. Any questions?
So based on your command line logs, it looks like you're using socket.io. What's the reason for the choice there?
Real-time communication, so it's a lobby system. So Socket.io has the built-in room functionality, so we can host multiple lobbies at once theoretically. The server doesn't perform well enough to do that, but it is there in theory that you could. So yeah, different lobbies basically.
So we have support for a lot of different categories that we're still building support for the top 100 animes or first animes on the right. So is there a reason why it needs to be sort of somewhat head-curated for each one of these categories, or is it just differences in each of, is Wikipedia consistent, so you kind of have to account for the inconsistencies in the categories, or what's the deal with that?
So generally that comes down to making sure we've got a good question. So we actually could have run those categories just then, but it fails every time to our heuristics of what we think makes a good question. Anime titles are really long, and that makes a really bad question because straight away it gets abbreviated into chunks that are very hard to recognize within the summary. So you'll get the answer straight away. It's very hard to filter that out. The random one, things are very random. Google Trends has no data for things like that. It's actually very hard to come up with suggestions for that. Yeah, I'll leave that there.
Yeah, fair enough.
On the heuristics you're using to create the question, did you write those yourselves, or are you using the library for them?
Yeah, they're mostly pretty primitive at the moment, actually. So it's things like the length of how many words are in the title. Generally, I think we're stuck to 3 at the limit at the moment. Things with brackets in the title tend to mess things up every now and then, so it will reject some of those. So what we get mostly at the moment are names, places, football teams, things like that. That's just ones that we know with what we had for the content remover part of the code would work reliably well, that we wouldn't totally spoil the answer every time. So, yeah.
So another question just came up actually. So Wikipedia has a lot of images as well, right?
Yes.
Have you considered using other types of questions than just fill in the blanks?
Of course we did. We had plans for multimedia questions, music questions, image questions. But as you can see, it's hard just to get to that point. We're happy to get to there, and that's good enough for a weekend. It's also very addicting to sit there and randomly generate questions endlessly.
Have you put any thought into how you might solve those performance issues?
Generally, I think the limit for that is we're using this random Python Wikipedia API wrapper that takes a very long time to poll the page and get it back. Ideally, we're not storing any questions locally, so there is always going to be some delay of requesting the site, getting it back, but that's part of not storing any questions long term. So, but we could strip that down a bit faster. One example is getting the lists of links. in one of the categories, we actually use pandas to get the list because that Wikipedia API is really bad. And it would only return 957 of the 5,000 links. So yeah, things like that. Thanks, everyone.
This is already up here. Next team is Screw Robotics. And then after that, Countdown Cowboys.
Let me get it. Oh, you come together. No, you're not. How do you put this up? Oh, there you go. Nice. Want to get this up?
Hello everyone. So I'm here to present Screw Robotics, and that's not just the phrase I say when my robots don't work, but that's also the name of our library that we worked on for this last weekend. So we're a bit of a weird one. We only started working on this like 3 or 4 p.m. yesterday. Just a bit about who we are. I'm Raghi and this is Miguel, and we are tutors for METR 4202, the robotics course at UQ. To give a bit of context on what a project is, we say that it's a library for robot motion planning using screw theory and Lie theory. And to explain what that is, we sort of have to explain what those things are. So screw theory is a mathematical formulation for doing rigid body kinematics and dynamics in physics. So there's a very fancy theorem called Charles' theorem that says you can take any rigid body complex motion and break it down into rotation through an axis and translation collinear to that axis. It's very elegant and you're able to do a lot of beautiful physics using this. But very connected to this is also the field of Lie theory. So if you guys have done discrete math subjects, you guys know what you guys might know what groups are. Lie group is a fancy version of a group where it's also differentiable manifold and has very deep connections to screw theory and lots of physics. It sounds a bit abstract, the group that is also a differential manifold, but a lot of things that we actually deal with in the real world are Lie groups. So for example, the set of all rotations is called the special orthogonal group 2 or 3, depending 2D and 3D, and all rigid body transformations, which is all rotations plus translations, they also form a Lie group. And the question is, what's the use of using all of this Lie theory and maths in the real world? And well, it's a bit complicated, but there's actually a lot of real good reasons for using this. So in particular, there's a lot of algorithms in robotics and aerospace and basically a lot of fields where you've got algorithms that work in Euclidean spaces, so your usual maybe position or velocity and whatnot, but you'd like to extend them to Lie groups such as your rotations or your poses. For example, if you've got a GPS that's really good at estimating where you are in your position, but maybe you've got a more complicated sensor system and you want to be able to figure out where you are in your orientation. So for example, you're a satellite. Now, to that effect, what we do in robotics is we sort of bring these Lie theory tools into robotics, and what we worked on is a library that actually makes a lot of this quite a lot easier to use. So Screw Robotics is a library that uses a Lie algebra based internal representation. We provide a very natural API for dealing with transformations abstractly, so playing around with matrices, or at least as little as possible. We use Pythonic code, so I've got all sorts of decorators and LRU caches and fancy stuff. And our only competition for this particular purpose of doing Lie theory-based robotics is one library from this one lecturer who's like 1900 lines of code, and there's no classes at all. It's literally just like a bunch of functions. It's awful. So here's some of the API. So all you have to do is you declare a transformation. You give it some screw parameters. So these would make your omega angular velocity components and your linear velocity components. You can very easily make homogeneous matrices out of this. So x.se3. It's actually very useful for game developers and similar too if you really want to use it. You can get the underlying Lie algebra, and you can also create identity transformations. You can take your homogeneous transformation back into your transformation representation. The nicer things is that it's actually quite nice as an API for robotics. So for example, if you've got a robot figuring out where the actual end effector or the gripper of the robot is compared to the actual base of the robot is actually quite hard. So what you can do is you can declare your base position and your screw for that define all of your joints, and you can just pass it in as, you can define your robot like this, and pass in your angles for your joints, and that'll give you your end effector pose. And one of the very nice benefits, for example, of screw theory is you get some effortless generalization. So for example, interpolation. If you've got some sort of rotation matrix or you've got some sort of pose, you can't just, you can't do the same thing as you do with translations. You can't just multiply it by some scale factor to figure out in-betweens. But you can actually do that quite easily with our library. So we've implemented operator overlaying. So if you multiply your rotations or your transformation by half, you will actually get a transformation that's halfway through that. We couldn't actually get to visualize because we only started yesterday at 4, but this actually works like this. So you can actually see these interpolation happening in screw theory. Cool. And yeah, I would like to remind everyone that we are interdisciplinary as well. So.
How will that lecturer who read the other library feel about this competition suddenly appearing? What's your response to that?
I think they need to learn to be better software engineers.
Thank you for making my maths degree actually feel useful, because I never really used it as But that's really cool. Good idea, design, from the looks of that.
It's pretty fun. We sort of teach a lot of this type of content in the robotics course, so if you did mechatronics, students probably hate us for making it so, hard, but you know, it's fine.
So that actually leads into my question, which is, do you see applicability for this library in the courses that you tutor?
Yes. Yeah, so we actually do tutor a lot of this content. It's just they have to write their own functions, and they're like they're using the same library with like the 1900 lines of. It's really nice to have if you can actually make this more convenient to use and more Pythonic. So.
Yeah, I think it'd be good to teach the conceptual ideas without really getting into the software.
Yeah, so a lot of our students are like mechatronics. A lot of our students are mechatronics, electrical, and mechanical. They might not necessarily like dealing with software, but if you can teach them the maths and the physics and just make the software a bit easier for them, that's quite nice.
Thanks very much.
Thank you.
Alright, next group is Countdown Cowboys. After that we have curly brackets.
Let me know when it's good. It's out on my computer. So it's going to be interesting because it's going to feed back. No. Yes. You might be able to play it off the computer if you can, but no.
So not through HTML.
Yeah, not through HTML.
Alright, let me fix that.
Only because of the feedback problem. Technical difficulties. Please hold.
Okay, cool. Ready to go?
Okay, hey guys, my name is Matt. My group members are Max and Harry, and we made Countdown. Now, you might not be familiar with Countdown, so I have a quick video here for you, just to run you through it. So, I'll talk over it. This it's a game show in the UK. There's two sort of rounds they play, letters and numbers, and basically, given 6 numbers, can you find a particular combination? That's the numbers game, and then the letters game is given 9 letters. Can you come up with the longest word? Okay. So this is fun. You can see
It's got some fun music. Here's an example. So have a think to yourself, can you solve this one? I'll give you a hint. This guy can. Cool. So that's enough of that. So we made a web app version of this. It is peer-to-peer, so you can play with your friends. We used Node.js and React for that. Just fun stuff. We got most of the way there. We didn't deploy it yet, but I'm sure we can do that in good time. There's a few things we want to add. So things like changing the number of consonants and vowels you have in games, and choosing the number of small and big numbers. And there's also a game called Carrot in the Box, which you guys might know about if you're a fan of Countdown, that we want to add in. But if you haven't heard of Countdown, no one will get that at all. Cool. So, we made a game, may as well play it. Let's do a quick demonstration. So I'm going to quickly turn that off. There we go. I'm going to make a lobby, and I'm going to play it with Max and Harry here. So if I create a room, just join my room ID, let them type it in.
And we also thought that the judges might want to play.
Okay, so I'm going to start the game, and just be wait, please don't spam it, because okay, let's go. Whew. Anyone got a suggestion? What do I put in here? 10 times 9 times 9. Oh, that's not gonna be good. Ooh. Yeah, that was pretty garbage from me. Well, it looks like we all scored 0. That's a shame. Never mind. We can play letters instead. So let's play that now. Okay. Anyone got a word? Just yell it out.
Greeny.
I had green. And there we go. So you can see it. It's come up with the solutions for us there as well. So telegony, classic. Yeah, so that's our game. Hopefully you like it. Oh, shut up. Okay. And yeah, that's it. Thanks for listening.
Yeah, it was pretty insane over live, and you actually recreated it pretty well. I just got one question: where are you pulling the questions and answers from? Is that like a countdown page somewhere on the internet? And program?
Just randomly generated them.
Randomly generated them, yeah. Fair enough.
So with the numbers, in the actual show, they'll give multiple, if there's multiple ways to get to a number, they'll give you the multiple ways. Are you just doing the one way you generated it, and then if someone comes up with a way verifying it, or are you actually like computing extra ways?
I computed every way to do it. If you switch to screen share, you can actually see quickly.
Sorry, one sec.
So you can see it gives you a solution. That's one of many, but we do verify what you put in as well.
Yeah, thanks.
Yeah, so you were saying you haven't deployed this yet. What are your plans for world domination of this game?
I mean, my grandma loves Countdown. I love Countdown. My goal is to be able to play it with her.
It's the only reason we made it.
Yeah, I mean, yeah, I kind of dragged them into it. Yeah, so that's the goal.
Do you have any localization plans to make it more Australian by renaming it to letters and numbers?
No.
Bringing in Lily's home.
We only know it as countdown.
I always tell people I'm making countdown. They're like, "What's that?" And then they go, "Oh, letters and numbers." Okay.
You're in Australia. That's what you get. Sorry.
Fair enough.
Thanks, guys.
Thank you.
All right, up now we have curly brackets, followed by, I'm going to butcher this, kongi.
Oh, do you have a USB-C? Oh, yeah.
Hi everyone, I'm James and this is Deep from Curly Brackets, and over the weekend for Hackathon we thought we'd make a bit of an itinerary planner. We're not really allowed to go anywhere right now for COVID, so we kind of thought, you know, we can dream a little bit and plan a holiday, just basic level. So we wanted to make it interactive as well. So we wanted to have some kind of fun element in that we'd, you know, aggregate some resources together about like things you can do on a holiday, you know, like flights to it, like prices for flights, hotels, you can stay at restaurants, like attractions, weather, things like that. And we wanted to kind of somehow get that and put it into a bit of a game format. So I think you'll see in a sec, but we didn't really think about the idea for very long, and I think that probably did not serve us well. So we kind of just thought, oh, let's, you know, make a car game and run it, and you know, it was not very well thought out. Like, we're not really thinking far into the future with this. It was kind of just make a little short game. So we did everything in React, and that was probably also a mistake as well because we had never used React before. We hadn't even like looked at it before the weekend. So we kind of did our best to get it all working. Like, there's no database stuff, unfortunately. But yeah, so we just looked online for a few APIs that we could use to get this data because we needed some way to get it somehow. And we decided on the free site, which is, it was basically the only way to do it because the APIs that did provide us information you couldn't get because they were either like locked behind some authorization. So we kind of had to go for like the worst free version, which also meant that it was really unreliable, and we were also getting a lot of things back that we didn't want. And it was a whole big debacle basically, like, you know, rate limiting and just not really getting much stuff that you want. But I think overall we did an okay job with it. So we basically decided there's an input form, the user inputs some data about the, so the user can input some data about where they want to go, things like that, and then we go online, get data about it, and display it in a nice card game. So I will hand over to Deep for a demo.
Right, so what we've got. Okay, so initially when you get into the website, you're going to want to put in. Oh, yeah, sorry.
I have to zoom back out. Yeah.
Okay, so you put in like your general idea of where you want to go, what date, what's your budget, and our website will use our APIs to grab some data, and then we will see, just with this stuff, we can see some stuff about the place we want to go to. And it's represented in this kind of game world where you can drive alongside buildings and it will show you possible hotels, for example. So in this hotel, it shows you the ratings, it shows you a little overview, and if that's not what you wanted, you can rewrite some information here and re-request. And so, for example, let's just,
it'll show you multiple hotels. So you can scroll along and see, just like that. And then also, alongside that, you can get to restaurants. That's a horrible picture we've got from our API, but I assure you this is a very good restaurant. Look at, this stuff is much better. But, yeah. Then you can also see the weather around the place. This is all forecasted weather that our APIs get, and it's represented as a graph. And you can also see attractions in the same kind of format, as well as flights. And so using a external widget, we can like create flight ticket parts and that. Yep. And then, yep. Done, yeah. That's about it.
So you're using React for the first time.
Yeah.
How do you go putting together that game visualization in React?
This?
For the first time? Yeah.
Well, not well. It's a bit of a like position absolute, and the cars aren't actually moving. The background image is moving, so it really like. It's not. It's like the most hacky way you can do it, but it worked for this. It also doesn't work in different resolutions. Like we had to make sure this was at 1440p because like that's what my screen was on. Otherwise, it's just not going to work. And I mean, you can see. We can just keep going if we want. Like, there's no stopping. Like, also these little sliders don't work. They don't do anything. It's more of an illusion of choice kind of thing. Huh?
Give you max speed, max acceleration.
Well, it doesn't do anything. No, it's the illusion of choice right now. Like, it's not going to change anything. Like,
He's going so fast.
It's a bit of a placebo, but yeah.
I just have to point out that you're scrolling and it's altering the acceleration option while also moving.
This was the most last minute thing. There's a reason it doesn't work.
That's
like,
so good.
Yeah, anyway.
I really love the idea. I really love how you kind of like, I don't know, made the process of looking for stuff in a location a little bit more exciting than just, browsing some blog,
Well, it wasn't supposed to be like very intense either, because you can always go to like websites that will do it better than you. It was more just kind of to aggregate everything together a little bit and make it in a fun way. Yeah.
So going forward, if you have more time to work on this, for example, so how would you make it a little bit more fun besides fixing the bugs that
Well, probably 3D. Like move everything to a 3D world, and we'd also want to procedurally generate some things. So if we go back to restaurants, if we're in a 3D world, we got 17 restaurants that it's found there, and things for hotels. So maybe we could have like a hotel for each of those ones instead of just having like a scroll where we have to look at it in this format.
Sounds almost like we're going to take the entire truth of your website, right? Just like
Yeah.
and just like very good the hotels in the game. Cool.
Yeah.
Cool. I love it. Cool.
So this sort of information is really big business, and I can understand why you have difficulty getting to those APIs because that's how these places make their money. Would you look at commercializing it in that way to get better access to the data and more timely data? And if so, how would you monetize it, do you think?
Well, that wasn't really part of the goals. As I said, this idea was very rushed. Like, we came up with this in about 10 minutes. So we didn't really think about like how we're going to move this going forward, and that's why it looks the way it does. So I think so. I do remember looking up some of the like terms and conditions about what, like, if you were to get an API key to get this information, like what you would have to, like how you would have to use it. And I don't think this is like an applicable way that they would let you use it for. So I don't even know if they would like accept this in the first place. So we kind of just have to deal with like the wraparound proxy APIs that are free. Yeah.
Sweet with TripAdvisor.
Yeah.
Great. Thanks very much.
Thanks.
Thank you.
All right. Now we've got Kongi and followed by notSomeone.
All good. All right. Hey guys, we're Anhad and Tyrone, and we want to show you a tool that we've been working on over the weekend, Bingo Butler. So games, video games, you got old games, new games. What happens when you get tired of games? You start speedrunning. You're like, oh cool, I'm bored of that now too. What do you do then? So most speedrunners, what they do is they play this game called Lockout. So you try to make it competitive, so you try to do different challenges on a board, one faster than the other. Whoever does claims the most squares on the board wins. Not most, but half. You can set that value, I guess. So let me play by a lot of people. So the process we've came up with to streamline this for people to use the tool that we made is you have a Discord bot, you make a text channel and you give different ideas, type start, and then participants can react to the bot and participate in the challenge. You send a URL and you just click it, hit play, and so now I guess we'll demo it.
Yep, so here's the Discord.
Not streaming,
oh. How do I do that?
Still not.
The exit this, whoops.
Just click escape.
Yeah.
You got
How do I get to that? Sorry.
Mirror it.
Sorry. Okay.
There you go.
Yeah. So
Hardest part wasn't actually making it.
Yeah. So we've set up Minecraft and Breath of the Wild bingo text channels. We've just put a bunch of tasks to complete in there, and when we press start, it just picks a random amount from that list. The default value is 3, so I'll just
the board size.
Yeah, the board size. I'm sorry. So this is how you get to participate in the game. You just react to this message, and it'll send back a URL that all the players will have to click. Since these are new users at the moment, we'll have to authenticate via OAuth. After authorizing, we're currently in the game. The color of the background matches what color they're ticked off on. So say I'm completing a few here, and it will reflect on the other players' screens as well. And when you get more than half of the board, it'll say on the website who won, as well as ping whoever won just in the Discord as well.
Yep. So the entire point of this project was just making this entire process really, really streamlined for people to use. Because there's tools that exist that do the same thing, and obviously you can use a pen and paper. But it's hey, why not just make it better? So the tech stack we used was this, I guess. Next.js for front end, Discord.js for communicating with the bot, and OAuth to Socket.io to reflect the changes, MongoDB store everything. Bootstrap for CSS. So one thing we wanted to accomplish was make this a really cohesive, polished experience. And we had to look into Discord OAuth to do that, which we'd never done before. Very interesting thing. And I guess one thing we especially wanted to do was no password. And you can see that it works really well. Most of the time when you go to a website, you're like, oh, I have to type password, copy paste it. What is it? 1, 2, 3. Oh man. Yeah. And so that's that. Future stuff we kind of hoped to do was brilliant ideas we came up with, but no time. What can you do? Was render the bingo boards with Godot in a 3D environment. I bought an asset back that I wanted to use, and we got that set up. The headless was a headless server version of Godot that we used. We got that set up, but we never got the message embeds working on the Discord. Hopefully in the future we get that done. And obviously traditional, it's called bingo what is
Bingo
it? Bingo
Butler.
Butler, but the game is actually called Lockout. So we'd hope to do some kind of bingo situation where if you get rows, it ticks it off. You did it, yeah, and you can like mind games the other person into going, well, am I going to complete that row? So challenges we faced, Discord.js just recently upgraded to like version 13 instead of 12. That's epic. It broke everything. All right, cool. Thank you.
Okay, quick question then. How do you verify that people are actually achieving the challenges? Is it an honor system?
It's just an honor system, yeah. I'm sure there's you could have like an adjudicator or something authenticated through the Discord that's verified to go, yeah, cool, you go do the thing. But we were just trying to replace a tool that already exists and make it better. So.
Yeah.
I mean, I know a lot of like speedrunning and stuff, you should like to stream their stuff on Twitch.
Of course.
So have you considered other kinds of authentication? So I know you use Discord. Have you considered maybe integrating, if you had more time, obviously?
Yeah.
Twitch streamers,
Twitch streamers, yeah.
For the streamers, you know?
Since that's the target audience,
it
would be great to have that kind of integration.
But the thing is, right, that's great, but if you, in the demo, we like used your username to like mark off that you actually did the thing, yeah. I'm sure there's actually probably a way you could do that with Twitch, but through like using the chat system, because again, it's just chat. But I'm not sure Twitch has a bot API, but yeah.
Twitch does have a bot API.
It does?
Yeah,
Oh,
so
that's
it's
sick.
pretty cool stuff. How do you guys actually manage the ideas that come through from the like different concepts of that? Because you just have them like more text.
Well, we were planning that like, hey, here's a Discord chat, shove all your messages in there, and I guess you can vet them, people can vet them if they want, and when the time comes to actually start a game, when you type start, it just gets all the messages and you're like, ooh, only select people who posted in that chat, get their special messages, and I'm like, on the board, yeah.
I do really love the idea of like lockout, but bingo, make the tic-tac-toe, but it's not.
But it's not, isn't it? It's not any of these things. Incredible. Thank you. Thank you.
All right, second last team, we have notSomeone, and then finally we'll have Team Webscape.
Is that full screen?
Yeah, it's full screen.
Cool. Hey everyone, we're Team notSomeone, and we decided to make an app called Someone over this weekend. This is our team. I'm Blake. I'm a first year student here at UQ. This is Edward and Christina. So kind of the goals for our project, this is actually our first hackathon, so we've never really done anything like this before. For us, it was also like a really good learning experience. I've never learned, I've never used Django before, and I've never built an API, so that was kind of my task. And then for Edward, well, none of us have built a Swift app before either, so it was a good learning process for us to be able to build a Swift app and then use Swift and Swift UI. Learn version control, that's something I'd never used before with Git, so I was just kind of, I think I was just like pushing to main the entire time, so I don't think that's quite good, but it worked in the end. And we also wanted to apply like a third-party NLP model in the app that we're building and kind of just have some fun with it. It was overall like just a really good experience and lots of fun just to push yourself to just build something new that you've never done before. So what is Someone? So Someone is a user-defined chat bot. Someone can be anyone you want. It can be a friend, a philosopher,
software developer, etc. Yeah, the goal, and we also came up with this idea because it was, during COVID, some people might not have anyone to talk to, so maybe they want to have a chat to someone and use the app. So tech stack, we use Swift, a Django REST framework, and the NLP model is GPT-3 by OpenAI. And yeah, Edward's just going to give you a quick demo now just to show what it's like. I can't see the mouse. Okay.
Sorry, technical difficulties. Oh.
Yeah, the mouse has completely disappeared. But,
Sorry, it's my laptop. It happens sometimes. It's okay. Well, actually, I don't know how to fix it.
We were going to jump into a demo, but basically the user can define, what's that? Oh, right. The user can define some parameters for the model. So they include what type of person they are. So the user enters their name, and then they can define what kind of, some parameters for the model to try and behave like. And it's really cool. So we basically feed in the entire chat history into each request. So the model learns over time what the user is like, and you can actually build a really interesting relationship with the model. So it's really fun. Like, we spend a lot of time just messaging someone, defining different characters, different people. Yeah, it's really, really cool. It's a really, really interesting piece of technology. Yeah.
So to also implement it, we also had to do some filtering of the speech and stuff like that to make sure that it's, it doesn't behave in the way that inappropriate. We did implement that as well. Unfortunately, we can't show it on the screen right now, but after we're done with our improvised presentation, maybe you guys, anyone can have a look and have a play with it. Yeah. So, anything else?
Yeah, that's about it. So the filtering is a really important aspect. That's a part of the legal responsibilities for us using GPT-3. And we were going to show a live demo, but technically it's not live because the company doesn't allow us to do live demos, but it does actually work. Yeah. Cool, thank you.
Very cool. I really like the idea of learning the personality and the sort of conversational style and keeping that going. Is it straight up text? Can you talk to it and it'll talk back?
We haven't implemented that feature, but it honestly wouldn't be hard.
I think that would be the real goal, is you can talk to it and it learns about you.
Well, technically, we did try to do that just in with Python sort of script type thing. We just haven't done it in the app, but it's pretty fun. Yeah.
Would you say this is a substitute for human interaction? Is that the intention?
Definitely.
Yeah.
I'm going to say, this is my favorite kind of technical difficulties, the one where it is your laptop operating system failing you and not your own app. Love it. So, where did Django REST fit in, and how are you using that?
So, obviously we're pretty new to Swift, and I didn't know if we could actually call the API or the model directly from Swift, but I guess the Django framework comes into play in terms of just because you create an account by actually just submitting your first name, and then it uses a token to store your data. So basically, the Django REST framework takes that initial request. It actually stores all of the messages, although the Swift app technically does that as well.
and then basically to feed in all of the previous chat history, we pretty much just get that from the database and put it back into the model again on each request to the model. And then also when the model sends a message back, that's stored back into the message chat. And then also we're calling the GPT-3 from the Django app or Django API, and we're also doing the content filtering through that as well. I guess another thing that we didn't implement in terms of filtering is just on the user side. If you were trying to be malicious, you could just say a bunch of random stuff, but what we have done is just filter what you get back. So, yeah.
How are you differentiating and defining those different personalities you talked about?
So they're actually all user defined. So that's the interesting part. The parameters are up to the user to define. We have to put in some parameters like politeness and trying not to swear, because the model has a tendency to be a little racist sometimes. So that's where the filtering is really important. So that's why we have the API essentially in the middle to make sure that stuff doesn't come out. But yeah, so it's really funny. We actually use the model itself to filter itself. So yeah, I don't know. It's interesting. Yeah.
Great, thanks very much.
No worries.
Okay, and finally tonight, our last team is Team Webscape.
Hello. Hi, we are from the Webscape team, and yep, sorry, we don't have any slides. We just go straight to the live demo. And so our project is an analysis of the world currency exchange market. The foreign currency exchange market is the biggest financial market in the world. It exerts an enormous impact on the markets because the currency presents the price of any asset, and its value represents the country's economic status. The forex market is a typical complex system and can be presented by the correlation networks and minimum spending tree. In this project, we analyze a set of 58 major currencies during the COVID-19 period by using the centrality measures, which are instrumental in most network analysis. So the first visualization is a heat map. It simply displays the results from the correlation calculation to provide an overall understanding of the relationship between currencies. It shows that the currency tracking geographic regions which are close to each other are highly correlated to each other. In addition, we can see the strong negative correlation is hardly seen between currencies during COVID-19. The next one is a network graph using to provide a more accessible method to convey meaningful messages. Information on the correlation between asset classes can be particularly useful for investors wanting to diversify their portfolios. The network graph could help the audience invest in assets that are uncorrelated with each other. Moreover, it also facilitates the analysis of forex behaviors. Instead of investigating all the currencies, the investor could save time by choosing to study the currency that represents the cluster. And the final visualization is a minimum spanning tree. It essentially provides a segmented graph, minimizing the number of edges and express the clusters in the network graph more clearly. The analysis shows that the Chinese currency is the most influential currency among COVID-19. It is a little surprising since some previous studies show that Chinese currency appeared in the lowest linkage during the past period. Some major global currencies such as Europe or Canadian, however, exist in the lower linkage. Yep, that's our presentation. Thank you for listening.
So, Forex trading is obviously something that people use to make a lot of money. Do you envision this analysis being useful for people who are looking to make a quick buck off Forex?
Yes, it is useful because I did mention that by analyzing the behavior of the currency network, we can diversify the portfolios. So we will not invest in the same currencies. We invest in the two uncorrelated currencies to maximize our profit. And we can also recognize some most influential currencies such as the Australian currency or the Chinese currency. So the investor could pay more attention to those currencies, so they can make profit from that maybe.
I had some really cool little animations there on websites, like the minimum span tree, for example, you could track it around. What sort of technologies did you use to sort of build this analysis?
So we did generate from the data. So we did generate core API from the website, and we generate data by using MATLAB script. So we output the network, and when we have the JSON file of the network, we put it to the D3 library, and we create a network graph in this site in the website.
Have you had any thoughts about localizing the data and considering what the impact of Forex trading would be if you were in Australia versus, say, in Singapore?
Yeah, you can see here, the Australia in the minimum spanning tree. It has the Bitcoin centrality. The value of Bitcoin centrality is highest because it is the biggest node in the minimum spanning tree. So it tells that the Australia can influence other currencies like stronger than the Singapore. So by that we can analyze the Australian currency to study the behavior of some other currency.
Thanks very much.
Thank you.
Alright, and that concludes the project. So let's give everyone a quick round of applause for all the projects we've seen tonight. You all should be very proud of yourselves. It's an awesome project we've seen tonight. Alright, so importantly, now it's the audience decision. There is a $200 prize for People's Choice. If you head to link.uqcs.org/People's Choice, then you have your teams there to decide from. And I'll bring us back up in a moment. And now we have Dijkstra's algorithms for one more time, and we will have food outside as well. Don't forget to vote.